Hey everyone, got a video on molarity and concentration. So the first question is, what is concentration? So I have a picture here, and you can see that we have very concentrated drink or chemical, I'm not really sure, right? Very concentrated, and then the word diluted here. So we want to know what is concentration. I think intuitively we all have an idea, but what does that actually mean? We can say that this is more concentrated than this, but what are we actually talking about? Well, with concentration, we're actually looking at how many dissolved particles there are in a certain amount of volume. So if we zoom in to the particle level, I know it's kind of blurry, but if we zoom in, we can see that something that's concentrated, this darker blue color, has way more dissolved particles in the liquid than a dilute solution, which has much less particles dissolved. So concentration has to do with how many particles there are that are dissolved in a certain amount of volume. So we know roughly what the idea of concentration is, right? The amount of something that's dissolved, but how do we actually measure it? To measure the concentration of something, we're actually going to use a new unit that's called molarity. It gets abbreviated with a capital M, and the way it's calculated is we take the moles of the aqueous species, so the moles of whatever is dissolved, and we divide that by the total volume of the solution measured in liters. So moles per liter is another way that we show the unit molarity, moles divided by liters. And that's the unit that we use to measure concentration. So what that ultimately means is something that is 4.5 molar, or 4.5 moles per liter, same thing, is more concentrated than something that is 1.0 molar, or 1.0 moles per liter. So what that means is this guy has more particles, more moles of aqueous species dissolved per liter than this guy does. So that's a bigger concentration. All right, I tried to show this video in our discussion when I first introduced or showed you molarity, and it didn't work. So let's try it now, and hopefully that's a little better. Okay, so that video was Tyler DeWitt. I don't have the YouTube link. I found it on social media, actually, so that's why I videotaped it myself, but give him all that credit. Okay, so let's do some practice. 4.2 moles of lithium fluoride is dissolved in 200 milliliters of solution. So a couple of quick things. We know that there are 1,000 milliliters in 1 liter. So if I have 200 milliliters, I can divide that by 1,000 milliliters to get the unit into liters. That way, when we divide, the milliliters cancels and we're left with liter. Or I just move the decimal in my head 3 places, so we should get 0.200 liters. So that is something you will need to be able to do this unit. Okay, so we know molarity is equal to moles divided by liters. So I want to know the molarity of 4.2 moles divided by 0.200 liters. Oops, sorry about that. Plug that in my calculator, and I get molarity is equal to 21 moles per liter, or 21 molar. Here's another one. 33 grams of beryllium hydride are dissolved in 6 liters. Well, in order to do molarity equals moles over liters, we have 6.0 liters, but we need moles, and they gave me grams. So I need to go from mass island to mole island. I have 33 grams of BeH2. So I know that to go from mass to mole island, I need 1 mole on top and the molar mass on the bottom. So let's find that. The molar mass of, we have 1 beryllium, 9.01, plus 2 times hydrogen, 1.01, gives me a molar mass of 11.03 grams per mole. And so I already have the 1 mole part taken care of, but that's 11.03 grams per 1 mole. So we take 33 divided by that answer, so that way grams cancels out and I get 2.99 grams of BeH2. That goes on top. Oh, excuse me. Yikes. Let's try that again. Moles, because grams went away, so it's 2.99 moles. We take that many moles divided by 6.0 liters, and my molarity is equal to 0.498, and we'll round that to 0.50 moles per liter. Number 3, how many grams of sodium sulfate are dissolved to make 2,500 milliliters of a 2.1 molar solution? So we know molarity is moles per liter. I have milliliters, and we know that there are 1,000 milliliters in 1 liter. So move the decimal 3 spots, I get 2.500 liters. So molarity, let's do this. They told me molarity. Where's my eraser? They told me molarity, 2.1 molar, so we'll say 2.1 molar is equal to, and we have 2.500 liters. So let's solve for some number, we'll call it x of moles. Well, I'm just going to crisscross multiply this guy, and this is like over 1. So I get 2.1 times 2.500 equals 1 times x. So x equals 2.1 times 2.500, 5.25 moles of Na2SO4. But they didn't ask for moles, they asked for grams, so we need to go from mole island to mass island. 5.25 moles times 1 mole over the molar mass of Na2SO4. So let's calculate that real quick. I'll do that up here. 1 times 22.99, two of those, 2 NAs, 1 S, 1 times 32.06, and 4 oxygens, 4 times 16. That should give me the molar mass of 142.04 grams per mole. So I have the per mole part, so we'll do 142.04 grams. That times 5.25 divided by 1 mole, so mole cancels, gives me 745.71 grams. So what that means is I need to dissolve 745.71 grams, or 746 grams, of the Na2SO4 in 2,500 milliliters to make a 2.1 molar solution. The other piece that we're going to talk about is dilution. And we know what diluting is. If you've ever made lemonade from one of these frozen containers, right? It's very, very concentrated. Like, you would never just let this melt and then drink it. It would be very bitter. We always dilute it with water. In our class, we have 12 molar acid in the back. And that's very, 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 very strong. We would never use that for any reason in our class, but we buy it like that so we don't have to keep buying more and more every single year. This will last us for many years. But when we give it to you guys, it's usually 1 molar or 0.1 molar. So we need to dilute that. Well, how do we do that? Looking at this picture, we can see we have concentrated, and then less concentrated, right? We're making it less and less concentrated. That is what dilution is. And the only way we're going to do that is by taking a small amount, right? I can take a little bit of this, and we put it in a new container, and then we put that small amount in the container, and then we fill the rest with water. because by adding the water to the small amount, we are diluting it and making it not as strong. So there is an equation we can use to figure out dilutions. It's M1V1 equals M2V2. So that's M1 times V1 equals M2 times V2. M1 represents the concentration of the stock solution. So this is the strong stuff, like 12 molar. Volume 1 represents the small amount that we are going to remove. So let's say I take 10 milliliters of that guy. M2 is my new molarity, usually what we're looking for, could be what we're looking for. And V2 is the new total volume, so that volume of the stock, 10 milliliters, plus however much water I'm adding. So let's say I add 90 milliliters of water. Okay, usually your volume is in liters, but it is okay if they are both in milliliters. They just have to match. You can't have one in milliliters and one in liters. But if they're both milliliters, that should be fine. So then we can solve for the missing piece. If I take 10 mils of this strong stuff and add 90 mils of water to it, right, and I solve for M2, I would get 1.2 molar. So I would have a new concentration of 1.2 molar, which would be much safer to give you guys than the 12 molar. So let's do a problem. What would be the concentration of a solution made by diluting 4.5 liters of 4.2 molar to 25 total liters? So we got M1 times V1 equals M2 times V2. So we want 4.5 liters were taken of 4.2 molar, and the new total volume is 25. So we're looking for this guy. So let's solve. We're going to take 4.2 times 4.5. That gets me 18.9 equals 25 times M2. Divide both sides by 25. So 18.9 divided by 25 gives me my new molarity, which is 0.756 molar. So that is the diluted molarity, or the diluted concentration. All right, what would be the concentration of a solution by adding 250 mils of water to 45 mils of 4.2 molar KOH? Well, that's the starting molarity, 4.2 molar. And we know V1 is the concentration of the strong stuff. So they said we're going to take 45 mils of that. And we want the new concentration. That's my question mark. And then this guy could be 250, but that's just water. We're adding 250 to the 45 of this, so I'm going to add those together. The difference here is the last problem, they told us the new total volume. This one, we had to figure out the new total by adding 250 and 45. So we're going to take the left side, 4.2 times 45, and we're okay because they're both, the volumes are both.
45 is 189.
Oh, thank you, Alexa. They're both milliliters, so we're good there. And then 250 plus 45. So we'll divide both sides by that 295. 189 divided by 295. M2 is 0.641 molar, or 0.641 mole per liter. Lastly, this is a very common problem for what Mr. Charvella and I do when we plan our labs. So I have my M1 V1 equals M2 V2. I want to know how much of this strong 2 molar NaCl do I need to make a new volume, 250 total mils, that has a molarity of 0.15. So we are actually looking for how much of the strong stuff I should take. So think about it this way. I have a bottle in the back that's 2.0 molar, and I know for a lab that the class needs it to be 0.15 molar, and we need 250 milliliters. I need to know how much of this stuff should I take out. So we're going to take 2.0 times V1 is going to be equal to 250 times 0.15, 37.5, divide both sides by 2. So V1 is going to be equal to 18.75, and we'll match the unit milliliters. So here's what that means. I need to take, say like I have this strong bottle of 2 molar. I need to take 18.75 milliliters of it and put it in a new container. And then I need to measure 250 minus 18.75. Whatever is left, 231.25 milliliters of H2O. Right, so that new total would be 0.15 molar, and it would add up to 250 mils. 231.25 milliliters would be water, and 18 milliliters would be from the strong 2 molar NaCl. Hopefully that helps. Come to class with questions.